In this video, I'm going to explain why light cannot be a particle. And if you look at the little globe that I've drawn there on the left, which is representing the Earth, and the moon is on the right, I've got a little X there on Nairobi. And so let's say we're going to fire photons from Nairobi up to the mirrors on the moon and try and catch them coming back. Now, there's reflective surfaces on the moon. In the National Geographic in December edition 1963, astrophysicists at MIT were bouncing lasers off the moon in 1963. That's 6 years before NASA said they put men on the moon and they left the mirrors on the moon. It takes light approximately 1.3 seconds to reach the moon and 1.3 seconds to come from the moon back to the Earth. Now the thing is, the Earth and the moon are travelling around the Milky Way with the solar system at 230 kilometers a second. So by the time that a photon reaches the moon has shifted 300 kilometers every time a photon is fired. So even if light were a particle and you managed to hit a target on the moon, by the time it would come back to the Earth, the position on the Earth has shifted 600 kilometers from its original position. And for anyone who might try and argue and say, oh well, we calculate that, we offset the difference, so we fire in advance so it hits and come back. That doesn't work, because the Earth is rotating and the moon is rotating. So if you were to try and offset it, fire ahead of the target to catch a target, you might get one photon coming back very occasionally, but you can't get a steady stream of photons coming back. The only way you can get a steady stream is if a photon is a wave. So a wave hitting the moon will not hit it at the part of the wave which is furthest from the Earth. It's going to hit it off the side, and the wave that is propagated back towards the Earth does the same. Coming back from that surface will arrive at a location which is 600 kilometers from the original position. It's a different part of the wave that's coming back and being detected. Now, anybody with an academic qualification in particle physics will say, no, there must be some other way to explain this, because Einstein proved that light is a particle because it dislodges an electron in the photoelectric effect. And we have the standard model of particle physics, which is the most successful model of physics ever built around it. The problem is, first, that the photoelectric effect does not prove that light's a particle. It is a wave of light hitting an electron shell and being sent off spinning in vortexes, just like an ocean wave comes and hits a rock and it's sent off spinning in spray, thousands, millions of little vortexes. Due to the measurement problem of quantum physics, we only detect one at a time. And similarly, a low energy ocean wave will not cause spray to be formed when it hits a rock. It'll just lap against it. But above a certain energy, you get all these vortexes spinning off as spray. And the particle model is not successful. Particle physicists cannot explain beta decay, cannot explain charge, cannot explain how quarks work, cannot explain how mass is created, cannot explain how their theorized different quantum fields interact and operate, can't explain how the Higgs mechanism works, because there is no Higgs mechanism. They can't explain what causes an electron to move. They can't unify all their different forces, and they can't even explain what energy is. My model explains everything. It is consistent with all the evidence, with no anomalies and no paradoxes. Particle physicists have fantastic data, fantastic measurements, but they've completely misinterpreted the information. Here's two simple experiments for anybody working in a lab using single photons to prove further that light is a wave, not a particle. Now they're very simple. The first is where we have the standard twin slit setup. You have a laser pointed towards two slits hitting the back screen, detecting the photons where it arrives, and we get the interference pattern. Now you see where the laser is. What I say is turn it to 90 degrees angle from where it is. But where the photon is emitted is at exactly the same place. Now using the particle model, that photon should be fired off to the side. But what I'm saying has happened is we will detect it at the back screen beyond the two slits, even though they're at a 90 degrees angle, like the pencil is in the video, not head on. And remember, this is single photons. The other experiment is also very, very simple. We have the detector at the back screen. To either side we have mirrors on the bottom, on the top, as you see in the video there. And in between the laser and the back screen, the detector, we have an impenetrable block where light cannot penetrate. The tip of the pencil here is where each photon will be emitted. And what I'm saying is that even though the laser will be pointing directly towards the block, which is impenetrable to light, and the block blocks any direct path between the laser and the detection screen. What I'm saying is that because a photon is a wave, not a particle, the wave will propagate out towards the side and it'll bounce off the mirrors and be detected on the back screen, the detection screen. And we should even get some interference where those two waves overlap, right in the centre behind the impenetrable block. And for anybody who says that's because of the quantum effect, because the particle behaves differently whenever it's being watched, I can't argue with that. That's really a flat earth mentality. If somebody can't see something that's so simple and clear because of dogma and peer pressure, it's no longer science. So please, somebody try those experiments. So please like and share so somebody does. And there's a few other videos on physics and mathematics on my channel, including the proof that a second loop is impossible in the Collatz conjecture and proof to the Goldbach conjecture, both which are very simple and elementary, not very dazzling, and academics don't seem to be too impressed, which is a massive understatement. But science is not about what makes you feel good or what's popular. Science is about what is true. And they are mathematical proofs. Very simple, very clear, very absolute and indisputable.